Today we're looking at part 3 of probability. Today we'll be looking at combined event in probability. Okay, so without much ado, let's begin. We say combined events. Okay, we're looking at probability of combined event. Combined event simply means the events that looks at the probability of two or more events. It's a scenario where we look at the probability of two or more events. Probability, for example, the probability of toasting a coin and also the probability of rolling a die. Okay, these are two different events. So probability of looking at two or more events is known as combined event. Now let's take a look at basic example. Let's take a look at a basic example before we look at our tutorial. Before we look at our tutorial, let's take a look at a basic example. Now here, okay, here we say question 1. We say two coins are toast. Okay, this case we're looking at two coins now, two different coins. So we're combining a coin and another coin. So that's why it's a combined event. We're not to say a coin. Two coins are toast. True. Two coin are toast. So probably we want to ask you the probability of what happens thereafter. Two coins are toast. Show in a two-way table all the possible outcomes. So that's the first question, the A part of the question. Show in a two table all the possible outcomes. Show the outcome. So we say show all the possible outcome in a two-way table. Summarily, I would just say show the outcome in a table. Show the outcome. Okay. So if you give you this is a combined event. We're starting from the basics of combined event. So we have two coins that are toast. You can take a coin, and meaning here you have two heads, a head from one coin and a tail from that same coin, and then a head from another coin and a tail from another coin, or from the second coin. So when you have this kind of thing, we make a table. We call this horizontal side, we say coin 1. We make a table, we say coin 1 on this side, coin 1. Okay? And then we rule this table for the coin, for coin 1. So we make here we have probably head and tail for coin 1. So let's we have head and tail for coin 1. We have head. We have a head here for the first coin, and you have a tail here for this same first coin. So you know every coin has a head and a tail. Now, but the question says two coins are toast. So here we also have on this side we also have another coin. Okay, we call it coin 2. So we can write on this way. We say we have a coin here. We call it coin. We call it coin 2. Right? So here we have coin 2. Coin 2. So the same way we have head and tail. We have head here, we have tail here. Here is tail for coin 2. This way you have the tail. You have the tail, and here you have the head. The first one you have the head. You have the head, right? You have the head here. So this is coin 1, this is coin 2. Now what is needed from you, what they want you to tell is that you see this horizontal, you'll be matching horizontal or vertical. So if you match here, you have head. You match with here, you have head. So here I have head. So if I go to the first column, you tell what you have. We have head. You have a head from coin 2. You have a head from coin 1 as well. Okay, meaning if you look at the horizontal, you have a head here. If you look at the vertical, you also have a head. Here, you have a head and a tail. You have a head from this one and you have a tail from here. So you can say head, tail, or tail, head. Head, tail. Then here we have tail, head. We have tail from this place, and we have the head from this way. We have the head from here. And then this place we have tail, tail. If you match the coordinate, tail here, tail here. So we have tail, tail. So the possible outcomes are 4. These are the 4 possible outcomes. So we can they ask us for the possible outcome. These are the outcomes. We have head, head. We have head, You say comma or plus or. We use or in this regard in probability. So when you throw two coins up, when they land, is either you get head head, or when they land you get head tail, or you get head tail, or when they land you get tail head, or miss plus in probability. Okay, we studied that already. So you get tail head, you get tail head when they land, or finally you get tail tail. So for two coins, if you toss them once, these are all the outcome. These are all the possibilities. Okay, or you get tail tail. So these are the possibilities. So for combined event, we include not only two coins, we can have 3 coins. So when we have 3 coins, how do we designate that? In the case of, so this is for question 1. Now, what's the B part of the question before we go to question 2, where we talk about the 3 coins? The B part of the question says calculate the probability of getting 2 heads. What's the probability of getting 2 heads? So this is the B part of the question. The B part of the question says, what is the probability of getting 2 heads? What is the probability of getting 2 heads? So I'll just write probability 2 heads. So I put 2 heads, 2H. What's the probability of getting 2H? 2 heads. Okay, what's the probability of getting 2 heads? So what are the possible chances of getting 2 heads out of all the outcomes? The total outcome is 4. See that you get head head, head tail, tail head, tail tail. These are all. So the probability, so we say the probability of getting 2 heads is only one possibility, right? There's only one case where you can get 2 heads, which is this one. Only here. You can get 2 heads. The rest, there's no 2 heads anymore. So it's only one chance out of 4 chances. So probability, so in your answer they say probability of getting 2 heads is equal to, probability 2 heads is equal to 1 over 4. Is equal to 1 outcome of 2 heads over all the possible outcomes, all the 4 possible total outcomes. So probability of getting 2 heads is 1 over 4. Probability of getting 2 heads is 1 over 4. Now the other question that could come from here is, what is the probability of getting a head and a tail in any order? What's another question they can ask from this type of question? Question 1C. Another type of question they can ask is, what's the probability of getting a head and a tail in any order? Head and tail in any order. Meaning we have tail head, remember, or we have tail head tail, right? These are the only 2 chances. So there are only two outcomes of getting a head and a tail in any order. There are only 2 outcomes like that. This one, these 2 in the middle. Okay, these are the only 2. Head and a tail in any order. In any order means it doesn't matter whether the head comes first, the tail comes second, or the tail comes first, the head comes second. So that's the meaning of any order, in any order. So it means there are only 2 of such possibility out of 4. So the probability will be 2 over 4. So the probability of head and tail in any order is, probability of head and tail in any order is equal to 2 over 4. Equal to 2 over 4. And 2 over 4 is equal to simplify, can be simplified as 1 over 2 if you reduce to the simplest 10. Okay, this can be reduced as 1 over 2 or 0.5. Remember, we can add probability in decimal. Okay, or 0.5. Okay. If another question you can ask is, what's the probability of getting at least 1 head? What's the probability of getting at least 1 head? Okay, D. So let's include question 1D. What's the probability of getting at least 1 head? Question 1D. What is the probability of at least 1 head? At least 1 head. What's the probability of getting at least 1 head? Now, in this regard, we go back to all the possible outcomes. Now, if you go back to all the possible outcomes, you see the first one, at least 1 head means, what it means is that there must be at least 1 head. Even if there are 2 heads, no problem, you go to count it. At least, meaning the worst scenario, 1 head. If he has 2 heads, it's still counted, still part of what we're going to consider. At least 1 head is in this box, because here you have the 2 heads, right? It's going to be part of our successful trial. This one has at least 1 head. That's the second one. This one has at least 1 head. But this one does not have a head at all. So we're not going to consider this because it does not have at least a head. So anyone that has at least a head will be considered. Even if both of them are head, we'll still consider it. Because they say at least, the least should be 1 head. Okay? If they say at most 1 head, At most, one head, meaning only this and this. Only this and this one, most one head. But they say at least one head, so you must understand English very well. At most, at least one head, you count this one that has two heads, you count this one that has at least one head, and this one that has one head. So there are three. So the probability will be 3 over 4. Because if you count all of them, is 1, 2, this one, 2, and then this one, 3. So there are 3 possibilities of at least one head. That's this one, and this one. So there are 3 possibilities of at least one head. So the probability will be equal to 3 over 4. Probability will be equal to what? 3 over 4. There are 3 possibilities of head, at least one head, over all the possible outcome, which is 4. So over all the possible outcome, which is 4. So this is what is required for that question. So this is for two when you toast 2 coins. When you toast 2 coins. When you toast 3 coins, we use tree diagram. Okay, it becomes a bit cumbersome. But we can estimate it. We can estimate it first. Okay, 3 coins, question number 2. Now we're done with question number 1. We say 3 coins are toast. They're toast ones, 3 coins. 3 coins are toast. Show all the possible outcome. That's the first one. Are toast. Show all the possible outcome. Show the outcome in a 3-way diagram or table. Show all the outcome. So here we use tree diagram. But before we do that, before we use tree diagram, show the possible outcome. Before we use the tree diagram, let's even use our common sense to itemize this. Before we even look at using the tree diagram. Show all the possible outcome. Now here, if you have 3 coins, let's do it together. Okay, let's do it together. So if we have 3 coins, let's assume the first one you throw is a head, the second coin you throw is also a head, and the third one you throw you also get a head. All 3 coins gave you head. So this is the first outcome. Because now we are throwing 3 coins. The second possibility is you cannot have head, head, tail. Maybe the second one can be head, first one head, second one head, and then the third one tail. Another possibility, what is possible when you throw 3 coins, is that first one can be head, second one can be tail, while the third one is head. Another possibility could be the first one could even be the tail, while the second and third are head. This is head, and this is head. Now we are done with having first of all, we're done with 2 things. We're done with having all of them head. And that can only happen once, all 3 of them head. Right? All 3 of them head. Now, after that, we had 2 heads, 1 tail. But the only thing we did was to be shifted the position of T, of 1 tail. First we have head, head, tail. And then we shift the T to the middle. Become head, tail, head. And then we shift the T from the middle to the first position. We have tail, head, head. So we're done with having what? 2 heads and 1 tail. We're done with 2 heads, and 1 tail. You're done with 2 heads and 1 tail, right? Now the next thing, this is all 3 heads. This one is all 3 heads, all 3 heads. Now the next thing we should do is 2 tail and 1 head, 2 tail and 1 head. Then before we have tail, 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 all 3 tails. Okay, then the possibility will be complete. Now let's do for 2 tail and 1 head. So for 2 tail and 1 head, we can have tail, tail, head. Okay. Then we have 2 tail and 1 head in this regard. Then the next thing we shift the position of the head to the middle. We have tail, head, tail, tail, head, tail. We shift the position of the head to the middle. The next thing we shift the position of the head to the beginning. We have head, tail, tail. We have head, tail, tail. So now we've also succeeded in having 2 heads and 1 tail. We've also succeeded in creating 2 heads. We succeeded in creating 2 tails and 1 head. 2 tails and 1 head. Now what is remaining is all 3 tails. That's what is remaining that we need to create. So which means we now have tail, tail, tail. These are all the possibilities when you have 3 coins toast once. Okay? All 3 tails. So any questions that comes in this, we should be able to answer them. Any questions that come from here, we should be able to answer. So when you toss 3 coins, these are all the possible outcomes. Is either the 3 coins appears to be head, 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 or we have 2 head, 1 tail, head, head, tail, tail, head, or tail, head, or tail, head, tail, or head, tail, or tail, tail. So it's these are what we get. These are what we get. Is that okay? So we're going to use the tree diagram to solve this time. If you have what's the probability of getting in this type of question, for example, this is the A part, show the outcome, right? We show the outcome, the possible outcome. The B could be what's the probability of getting a head? What's the probability of getting 3 heads? What's the probability of getting 3 heads? So probability of 3 heads, probability of getting 3 heads, probability 3 heads. It's only one outcome where we have 3 heads. There's only one outcome where we have 3 heads. So we're going to say what? We're going to say we count all the outcome 1, 2, 3, 4, 5, 6, 7, 8. There are 8 outcomes. There are 8 outcomes, and there's only one of getting 3 heads. So probability of getting 3 heads, you say 1 over 8 becomes 1 over 8. 1 over 8. So that's the B question. What about the C question? What's the probability of getting at least 2 heads? The C question, what's the probability of getting at least 2 heads? Probability, at least. Okay, I'm summarizing. Probability of at least 2 heads. At least 2 heads. What's the probability of getting at least 2 heads? Okay. So we see how many chances or outcome do we have 2 heads? There are 3. 1, 2, 3. Okay, where we have 2 heads, at least 2 heads. Okay, at least 2 heads means we consider where we have all heads. So we have 1, 2, 3, 4. This is where we have at least 2 heads. So at least 2 heads equal to, probably get at least 2 heads equal to 4 over 8, which is 1 over 2. 4 over 8, if we reduce to the lowest term, we get 1 over 2. Is that okay? Now, another question that could come from here, what's the probability of getting 2 heads and 1 tail? What's the probability of 2 heads? Probability of getting 2 heads and 1 tail. So if they ask the probability of 2 heads and 1 tail, we already know how many are 2 heads and 1 tail. Only 3. 3 possibilities. 1, 2, 3. Only 3 possibilities. Probability of 2 heads and 1 tail. Probability of 3 heads and 1 tail. Sorry, probability of 2 heads and 1 tail is equal to how many? How many cases we have 2 heads? 1 case, second case, and third case. So it's 3 over 8. Probability of 2 heads and 1 tail is what? 3 over 8. What's the probability of getting 2 tails and 1 head? The same. Now, meaning they're asking for 2 tails and 1 head. Not at least. They just say 2 tails and 1 head. So probability of getting 2 tails and 1 head. Probability of getting 2 tails and 1 head is also 3 over 8. Why? Because there are only 3 outcomes for such category. 1 outcome, second outcome, third outcome, where you have 2 tails and 1 head. So it's also 3 over 8. Right? So we say 3 over 8. What's the probability of getting all tails? Is 1 over 8. Or at least 1 tail. At least probability of getting at least 1 tail. Let's do this one. Probability of getting at least 1 tail. Probability. What's the probability of getting at least 1 tail? Probability of at least 1 tail. So this one will be 7 over 8. Why? Why is it 7 over 8? The reason why it's going to be 7 over 8 is because there will be 7 possibilities where you have at least 1 tail. 7 over 8. Now how? At least 1 tail, there's 3 tail here, we go to count it. At least 1 tail, there are 2 tail here, we go to count it. At least 1 tail, there are 2 tail here, we go to count. So we have 3, 4, at least 1 tail, there's a tail here, we count it. So 5, 6, 7. So there are 7 possibilities where you have at least 1 tail. So it gives us 7 over 8, 7 over 8 possibility. So this is for this type of question. This is for this type of question. Now this question can also be taken in another form. Apart from you say 3 coins are tossed once. You see, 3 coins, you toss them once. What if I say a coin, just a coin, is tossed 3 times. Let's say question number 3. A coin, one coin is tossed 3 times. It's same logic. One coin is tossed 3 times. A coin is, so if they tell you 3 coins are tossed once, or a coin is tossed thrice, so it's same thing. But in this case, we're going to use, in this second scenario, we're going to use the tree diagram to get all the possibility we've talked about. A coin is toasted 3 times. 3 times. A coin is toasted 3 times. So I just write 3x, meaning 3 times. It's toasted 3 times. Show all the possible outcomes on the tree diagram, writing each of the probability at the side of the branches. We're going to write each of the probability at the side of the branches. That's the A. So we're going to show a tree diagram and put their probability. So the first thing we're going to do in this, we show the tree diagram, show a tree diagram. So here we're going to learn a tree diagram, how to use it to solve probability. Tree diagram and the outcomes and their probabilities. Tree diagrams, okay, and outcomes and their probability. So what we do, we say first of all, we write toast 1. So we're toasting the coin, we write toast 1. Toast 1. Because we're going to toast a coin 3 times. The first toast, we call it toast 1. The second toast, we call it toast 2. Toast 2. And the third toast, we call it toast 3. The third toast, we call it toast 3. We call it toast 3. Because we are toasting a coin 3 times. So we give this heading, toast 1, toast 2, toast 3. Okay? So, and then we put then here we put all, we're going to write out all the outcomes. I can put outcomes here, like we're going to show all the possible outcomes, whether it's head, 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 or head, tail, head. We're going to write out the outcomes for each of these. So we say outcomes. Now let's start. For the first toast, we go there a little bit because the diagram will be growing up. Growing, the tree will be heavy branches. So we go there a little bit and we say for the first toast, let's change the color to orange. Okay, for the first toast, we have head and tail, right? If you throw your fair coin, it's either it comes up with head or it comes up with tail. So probability of getting a head is 1 all over 2. So let's write the probability by the side of the branch. That's what they asked us to do. So you get head or tail, and probability of getting a tail also is 1 all over 2. This is for your first toast. For our second toast, we go to have here, we go to have, if we toast the coin the second time, is either we also have head and tail, right? The outcomes are head or tail. If we toast the coin second time, head or tail, right? And also similarly, here, you also have the same thing, head or tail. You also have head or tail. So every branch will be having its own 2 branch. The third case, we have, we also go to toast. Here we did put the probability, right? Each one is 1 all over 2. Yes, each one is 1 all over 2. Probability of getting a head for your second coin. You know it's a second toast. You take the coin, you toast again second time. Probability of getting a head is also 1 over 2. And probability of getting a tail is 1 all over 2. Similarly here, probability of getting a head is 1 over 2. And probability of getting a tail is 1 over 2. For the third toast, you take the coin again, you go to throw. So it's either we get head or tail. For this branch, here same thing, head or tail. Here, each of the branch you've arrived at, you also have 2 more branches for the third toast. So each one, probability will be head or tail. So here, for the tortoise, we're also going to have head or tail. For this one also, it's also going to have a head or tail. We're also going to have a head for this one or tail. This one also, you're going to have a head or tail. This is how to use a tree diagram to show it. Now, all the probability of each one, because it's a coin you've toasted this third time. So either your probability of getting a head is still 1 all over 2. Probability of getting a tail, because it's one coin, it's either you get head or you get tail. So probability of getting each one is going to be 1 all over 2. 1 all over 2. 1 all over. They want us to bring out all this probability in order to get the marks for this. 1 all over 2. 1 all over 2. 1 all over 2. 1 all over 2. Okay, so this is all you have. These are all the possible outcomes. Now, let's write out all the outcomes. So for the first outcome, you can see we have here head, head, and head. So here, we're going to be writing out the outcomes. We have head, head, head. Head, head, head. Okay, so the first case, you have head, this branch, head, this branch, head, this branch, head. So you have head, head, head. These are the outcomes for the first case. The second case, you have what? This branch, head, before you now branch this way. So you have head, head, tail. So for this second outcome, you have head, head, tail. Head, head, tail. For this one, you have head, head, tail. Why? Because you're just following the branches. Here, and then before you go down here. Because you've used the up. Before you go down here, you have head, head, tail. Then the next one is, we're still going to use this one, but we're done with this branch because we covered these two. So we're going to use this, and then go up this way. You get it? So we're going to go here, and then up first. So we bring out this one, the outcome, this outcome. So we have head, and then tail, and then head. So we have head, this branch, head, then we go this way. Because we're no longer going here because we've used these two. So if you go here, where will you go out from? You've used both. So here, then you go this way, which is tail. So you say head, tail, then you go up first. Head, tail, head. So you get this outcome. Head, tail, head. Or means plus in probability. Or you go here, this place, this branch. You also go this branch, but you now go down. So you have head, tail, tail. Right? You have head, tail, tail. So you have head, tail. You have head, tail, tail. This one. Then the next thing, we're done with this branch, right? We've used these two. So we go here now. No need to go here. We're done with this. Because we've used everything that has to do with this direction. So we go down. So we have tail, head, head. So here, we have tail, we have tail, we have tail, head, head. Tail, head, head. Then the next one, that's for this branch, is tail, head, tail, right? So the next one we have tail, head, tail. tail, head, tail. Right? So we have tail, head, tail. Then we now have, we're done with this branch. So we have tail, tail, head. This one. We have tail, tail, head. And then before we have the last one, which is tail, tail, tail. So this is what they asked us to show using a tree diagram. Tail, tail, tail. These are all the possible outcomes using a tree diagram. Is that okay? So the first questions that follow, the big question after this is that we should find the probability of what? It says, what is the probability of getting 3 heads? Okay, which is normal. We've done that in question 2. Probability of 3 heads, PR of 3 heads. Probability of 3 heads is 1 over 8, right? Because it's only one case where we have 3 heads. Only one outcome, we have 3 heads. There's only one outcome that has 3 heads, which is this first outcome. So it's 1 out of 8 outcomes. So you say probability is 1 over 8. So that's that for that question. So we go to the C question. What's the probability of getting 2 heads and 1 tail in any order? 2 heads and 1 tail. So we already know, look, 2 heads and 1 tail. 1, 2, 2 heads and 1 tail. 3. They are in any order. There are 3 possibilities. 2 heads and 1 tail. So we say 3 over 8. So the C question says, what's the probability of getting 3 heads and 1 tail? So what's the probability of getting? Probability of 3 heads, 2 heads and 1 tail, sorry. Probability of getting 2 heads and 1 tail in any order. In any order. It doesn't matter which one comes first. And 1 tail. Probability of 3 heads and 1 tail. Probability of getting 3 heads and 1 tail. Sorry, 2 heads and 1 tail. So how many? We have 3 possibilities. So we say 3 over 8. We say 3 over 8. Then the deep part of the question, you say, what's the probability of getting at least 1 head? Okay, this is similar to what we've done before. At least 1 head, count the one that has at least 1 head. There's 1 head here, we count. 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 There's 1 head here. There's 3 heads here, we count the 3 heads or 2 heads, but at least must have 1 head. So it's 7. So we say probability of at least 1 head is 7 over 8. Probability of at least 1 head. So I did write at least, I just put at 1 head. 1 head. At least 1 head is 7 over 8. 7 over 8. Okay? What's the probability of getting at least 1 head is 7 over 8. Is that okay? You can do at least 1 head is a probability of 1 minus probability of getting 3 heads. Probability of 1 minus getting 3 heads, you still get 7 over 8. Then the E part of the question says, what's the probability of getting no head? What's the probability of getting no head? Okay, the E part of the question. No head means tail. There's no head at all. So it's going to be 1 over 8. So probability of getting no head. Probability, no head. No H means no head. So if you're asked what's probability of getting no head, it means probability of getting tail, right? Which is 1 over 8. There are only one scenario where there's no head at all. So we say 1 over 8. Okay? So that's that for this type of question. So there are more questions on this one that we're going to look at. Maybe we take one more question before we go and look at our tutorial. Now let's say question number 4. Let's take this question number 4 before we talk about our tutorial. Question number 4. Question number 4. Now we say in winter, the probability that it rains on any one day is 5 over 7. Okay, so I will not write all the words. In winter, the probability that it rains on any one day is 5 over 7. Okay, in winter, the probability that it rain on any one day is 5 over 7. Now, it says using the tree diagram, show all the possible combinations for 2 consecutive days. For 2 consecutive days, all the combination for 2 consecutive. So they say using the tree diagram, using the tree diagram show all the possible combinations for 2 consecutive days. So it rained on one day. So we're going to have rain or no rain. So we say day 1, day 1, then we have day 2, then we have outcome, right? Day 1, day 2, and then we have outcome. We have outcomes. So if it rain, it's 5 over 7. If it does not rain, no rain will be what? 1 minus it rain. 1 minus it rain. 1 minus 5 over 7, which is 2 over 7. 1 minus 5 over 7, which is equal to 2 over 7. Which is 2 over 7. Is that okay? Okay, so now they say we should draw the tree diagram to show this. So we say, so here it rains. Here no rain. On day 1. So probability that it rains is 5 over 7. If it rains, probability that it rains is 5 over 7. 5 over 7 on day 1. If it doesn't rain, probability that it does not rain is 2 over 7. It's 2 over 7. Okay? Now on day 2, it rains or no rain. That's what we get on day 2 as well. Right? Same here. So on day 2, we have either it rains or it doesn't rain. Either it rains or it doesn't rain. So probability that it rains is always 5 over 7. So here we have 5 over 7. It doesn't rain is 2 over 7. It rains is 5 over 7. It doesn't rain is 2 over 7. So it rains is 5 over 7. It doesn't rain is 2 over 7. Okay, so what are the outcomes? Here we have rain. The outcomes are, because these are just 2 days, so it's just 4 possible outcomes. Either we have rain, it rain on the first day, and rain on the second day, or it rain on the first day, which is this branch. It rain on the first day, but does not rain on the second day. That's a possible outcome. It rain on the first day, but does not rain on the second day. Or, which other possible outcome you can have? Or, it does not rain on the first day, but it rain on the second day. So, it doesn't rain on the first day, no rain, first day, but rain on the second day. Or, does not rain on both days. That's another possible outcome. Both day 1, day 2, no rain. These are possible outcomes you can have. Both day 1, day 2, no rain. No rain. So there are 4 outcomes you can have. Either it rain on both days, or it rain on the first, does not rain on the second, or it does not rain on the first, it rain on the second, or both of the 2 days there was no rain. These are all the possible outcomes. So if they ask you to show the probability tree and the probabilities inside each of the branch, we've done that. They show the outcome, we've shown the outcome. Then the question they can ask again is for you to calculate the probability that it will rain on both days. Calculate the big question. Calculate the probability that it will rain on both days. Okay, so probability that it will rain on both days. Probability rain on both days means rain. Means rain on first day and rain on second day. So you simply come and you multiply the probabilities. So you come here. What's the probability that it will rain on this both days? Probability of first day it will rain is what? 5 over 7. 5 over 7. Probability it will rain on first day is 5 over 7. Multiply by probability that it will rain on second day, which is also 5 over 7. Probability that it will rain on second day is also 5 over 7. So when we multiply, this times this we get 25. And the denominator will get 49. So you cannot simplify further. So you leave it as 25 over 49. You leave it as 25 over 49. So that's the probability of it will rain on both days. Now, what is a calculate the probability that it will rain on the first, but not on the second day. Probability that it will rain on the first day, but it will not rain on the second day. So if they ask us to calculate the probability that it will rain on the first, so you look at which possibility it rain on the first but does not rain on the second. Is this possibility? This one. In this case, in this scenario, it rained on the first day, but it does not rain on the second day. Here, it does not rain on the first, rain on the second. Because they are only particular about it rained on the first day, but did it rain on the second. So we only have this outcome. So here, we're going to be calculating probability of raining on the first day and not raining on the second day. So we're going to be looking at probability of raining on the first day and not raining on the second day. So for this, since this is the only possible outcome, this is what we're going to calculate. So probability of raining on the first day is 5. Anytime it rains, 5 over 7. And on the second day, does it rain? It doesn't rain. If it rains on the first day, it's 5 over 7. Does it rain on the second day, it's 2 over 7. So we're going to multiply by 2 over 7. We're going to multiply by 2 over 7. That's why it's called combined event. We're multiplying them. Okay? So since we cannot just cancel out, just say 5 times 2, you get 10 in the numerator and 49 in the denominator. 7 times 7 is 49. So you get 49. So this is 10 over 49 for this probability. Is that okay? Then another question that we ask, the E, calculate probability that it will rain on at least one day. Probability that it will rain on at least one day. Now, at least one day means it will rain on both the one it rained on both days and the one it rained on one day. You must include them. There are 3 possibilities. So probability that it will rain at least one day, we're going to include those 3 outcomes. Okay? Probability of at least one day. Rain. Probability of rain at least one day. At least one day. So here we're going to include all those 3 possible outcomes. At least one day. So we say we're going to write this one out. It means it's the probability of rain on the first and rain on the second. That's arrow. Plus, we're using plus for or. We're supposed to say or. Rain on the first, does not rain on the second. Does not rain on the second. Or, which means plus, or does not rain on the first day, but it definitely rain on the second day. These are all the 3 possibilities. These are all the 3 possible outcomes. Okay, so probability of rain on both days, we already calculated that, don't forget. So we can simply write that out, or we do it one at a time again. So here is 5, rain on first day is 5 over 7, times, rain on the second day is also 5 over 7. We put bracket, we put small bracket for this. Then, there's or plus. You now say plus, you do for this one. Rain on the first day, which is 5 over 7, does not rain on the second day. Anytime it doesn't rain, it's 2 over 7. Say times 2 over 7. Anytime it does not rain, it's 2 over 7. If it rains, it's 5 over 7. It doesn't rain, it's 2 over 7. Then we put bracket. Then we do the next one. We say or means plus. It does not rain on the first day, it's 2 over 7. Does not rain on the first day, it's 2 over 7. Multiply by it rain on the second day is 5 over 7. So these ones we're going to bring out. We close this bracket and this one. Then if we like, we can put a big vast bracket. If we like, if you feel like. Okay. Then the next step is to do each one. This one is 25 over. You just multiply the numerator, you get 25 over 49 over 49 plus multiply the numerator, you get 10 plus 10 over 49. Everything will be over 49. They have a common denominator. plus, if you multiply this also is 10 over 49. So what it means is they have the same denominator. We're going to have what? We're going to have our denominator. In our final answer, we're going to write that 49 as our denominator, right? You write 49. Then you add the numerators together. You add all the numerators together. So 25 plus 10 is 35. 35 plus 10 is 45. So we have 45 over 49. So this will be the probability of at least it rains on one day, or at least rain one day out of the 3 days, 45 over 49. Okay, so this is the combined event. Now, before we call it a day, we listen to the tutorial before we call it a day, right? After the tutorial, I think we can just call it a day. Let's listen to the tutorial and then we call it a day. Okay.
So in this tutorial, we're going to look at combined probabilities, which is what you have to deal with when you have more than one thing happening. So two trials, if you like. Remember, a trial is an experiment, a probability experiment. And ways you might approach this are, well, you might use a tree diagram. Okay, you don't have to use a tree diagram, but it sometimes is a good idea, remembering that on each set of branches, the total probability must be 1. You're going to need to make a decision if two things are happening and it involves picking things out of a bag or a hat or a chocolate box or something. You need to decide whether the items are replaced. So is the first thing replaced before the second thing gets taken out? And if they're not replaced, remember that the numbers, particularly on the bottom of the fractions, go down by 1. We'll have a look at one of those in a minute. Whether you use a tree diagram or not, it's always a good idea to write down the probability you want with and or between the things, okay, as you would naturally say it. And then, once you've done that, and is always times, and or is always plus. Just pausing to note that the and rule, and is times, works for independent events. In other words, the first thing doesn't affect the second thing. And the or rule works for mutually exclusive events, which means the two things can't happen at the same time, like a head and a tail on a coin. They are mutually exclusive events. And there is a trick you can use, a couple of tricks here. It's often quicker and easier to use. Well, if you want to find the probability that something doesn't happen, so the probability of not A, it's often easier to find the probability that it does happen and subtract it from 1. And similarly, if you want to find the probability that you get at least one of something, find the probability that you'd get none of that something and subtract that from 1. And often the question will highlight a word which tells you to use that trick. So anyway, let's apply this to some questions. So here we have the box of chocolates with 8 dark chocolates and 4 milk chocolates in it. So that's 12 in total. And 2 chocolates are taken at random. Now, it very clearly says they're both taken out at the same time, but we treat that as one after the other without replacement. So these are clearly not replaced. In my experience, in my household, chocolates are never replaced. And we're asked what the probability is that they are different types. Well, we don't need a tree diagram necessarily, but we are going to draw one just to show you how they work. So, first chocolate can be dark or milk, and we put the probabilities on the branches. So the probability of a dark chocolate is 8 out of 12, and because there are 8 dark chocolates and 12 chocolates in total. And then the probability of a milk chocolate is 4 out of 12, for the similar reasons. And just note that, of course, those two things do add up to 1. And then we need to put a second set of branches on, okay, after each choice here. So if it's dark first, it can either be dark or milk second. And if it's milk first, it can still also be dark or milk second. And now, because we're without replacement, we need to be careful with the probabilities. So how many dark chocolates are left if we've already taken a dark chocolate out? Well, the answer to that is 7. But how many chocolates are left? Well, that's 11. And that's what I mean by the numbers going down by 1. The number on the bottom always goes down by 1 when it's not replacing, when we're not using replacement, and depending on which one you're taking, the number on the top might go down by 1 as well. Now what about milk chocolates? Well, there are still 4 milk chocolates left and 11 chocolates in total, and again check that those two add up to 1. For the second set of branches, well, there are 8 dark chocolates left but only 11 chocolates in total, and now there are only 3 milk chocolates left if I've taken one out, and 11 in total, and again the numbers are going down by 1. Now, whether or not we've drawn that tree diagram, we should now write down the probability with ands and ors. And it's perfectly okay to use D and M for dark and milk. So, what's the probability they are different? Well, it's D and M, or M and D. Now, if you think those two things are the same thing, just have a look at the tree diagram. There are clearly two routes through the tree diagram, and you can see there are two ways of getting different chocolates. So although you end up with one of each, you've got them in a different order. So let's now do the probabilities. So the probability of a dark chocolate, according to my tree diagram, is 8/12 and is times, and then following that first route through, I get 4/11 there. So that's that route there, and we're multiplying because it's and. It then says or, so we add, and then we follow this route through the tree diagram. As I say, you may be able to do that in your head without a tree diagram, but it's 4/12 for the milk chocolate, and then 8/11 for the dark chocolate. And if you do all of that, which you could do in your head if you like, that is 32 132ths plus 32 132ths, they turn out to be the same thing, which is 64 132ths, and that does in fact simplify to 16 out of 33. So there we go, there's an example of a combined probability question. Let's have a look at a slightly different one. Here we have a biased coin landing on heads 70% of the time. So the probability of a head is 0.7, and therefore the probability of a tail, of course, is 0.3, is it not? So let's actually just write that down. So probability of head equals 0.7, and the probability of a tail, which in fact you could call not head, head dashed, h dashed, is 0.3. Okay, now notice that there's a highlighted bit in the actual question. John tosses the coin 3 times. What is the probability that he tosses at least one head? And I think that's the question telling me to use this trick here. You could do it the other way, but it would take you a lot longer. So we're asked about the probability of at least one head, and I'm going to use the trick. It's 1 minus the probability of no heads. And so that's 1 minus the probability of tail, and tail, and tail. Now, I can just do my and or thing here. Actually, there are no ors, so it's just ands, and I get 1 minus 0.3 times 0.3 times 0.3. And if I do that, I get 1 minus 0.027, which is 0.973. Okay, so it's very likely I will get at least one head, which you would expect because, of course, it's biased towards heads. But there we go, I've used the trick at the bottom of the blue box there. Now, I know that these probability questions do get harder, and there is another tutorial with some much harder questions in it. So you might want to have a look at that too.
Okay, so you can see the probability, the tree diagram. We've explained this already. Okay, we've already explained this, and I think we should call it a day, right? We should call it a day for today's class. All of this probability, we've given you the example already. We've drawn the tree diagram, we've explained the tree diagram, how to use them, and we'll give you a tutorial. So we think you're good to go for this probability. Is that okay? So thank you for joining us.